Hello and welcome, guys. So, in this video, we would be understanding the basic idea or the program logic behind your merge sort. So, basically, merge sort is a sorting algorithm which basically it uses a approach that is called as a divide and a conquer approach. Okay, so let us for an instance we consider an array A of n number of elements. So basically our algorithm consists of three phases. First of all, see, there's a basic journal, anyone can understand it, that if a array contains zero elements or one element, if a array contains only one element, that means that array is sorted in itself, because if we have only one element, then what is the need of comparing it with another when there is no other element? Okay, but if we have more than one element, so what needs to be done? So this algorithm divides your array into two sub arrays of equal number of elements. Okay, so this was your first phase where you divide your array. Okay, and the second phase now, this comprises of your conquer, that is means to sort the two subarrays recursively using the merge sort. What that means is we got the two arrays, though they are a part of that single array only, but yeah, we got two sub arrays now. So now we have to sort those two sub arrays recursively, because if there are n number of elements, we have to apply this formula for n number of times. But yeah, recursion helps us to solve that problem also. So until we get our last value, we would recursively call this merge sort algorithm or our function when we code this, and after that we would combine those sub arrays, okay, to form a single and a final sorted array. Okay, if you haven't understood, no worries, let's check an example. See, our first condition, what does our first condition states? Our first condition states that there must be more than one element. Okay, we are having three elements, so calculate the mid is left plus right minus left by 2, so left is 0, right is 2. Calculate the mid comes out to be 1. This is your first step. Now your mid is at position number 1, your mid is here. Understood? So now your array will break from this point. Okay, so now this would become a separate array, and this would become a separate array logically, not physically, because it is all applying into your code. And after that, again we apply this merge procedure, merge sorting algorithm. So we got our mid to be, see, mid is 0 plus 1 minus 0 by 2, so 2 0, we would be getting mid as 0. So now this would be breaking our array from here. So now we got 11 and 1. So as per our algorithm, we had to sort those arrays until we find a single item, because if a array contains only a single element, then that array is already sorted. Okay, yeah. So after that we applied our procedure number 2, that is to sort and combine. See, after that we done sorting, we did sorting in our ascending order. So see, we checked that this array is smaller than our 1 is smaller than our 11. Okay, so we sort that and we combine that. Okay, and after that what it does is it goes here to our part number 2. See, recursion works in a simple way. As first we would be solving a particular half until we got our answer. Yeah, so now after that it gives us 12, so now we would sort this also, and it gives our array to be 1, 11 and 12. See, pretty simple. I hope you understood till now. Okay, so guys, now we would be talking about some of the code, that how to approach to a particular solution for your merge sort algorithm. Okay, see, this is your code for a sort. What did your sort procedure do? See, took an array in left and right means what is your left? This is 0, right is your array dot length minus 1 in Java. If you say in other programming languages, you can find out that way. And now calculate mid. mid is left plus right by 2. Yeah, but my this formula is good, as if you find out mid, because for n large number of elements this formula suits better. So I recommend you all to try this. But yeah, this also works. Okay, don't think that this formula won't work. It works fine. Then we sort this array using our array left and mid. What that means is sort using our array, using array left and mid. So for now, see, left, mid, and your right. Left is 0, mid becomes 1 for this part, and right is your 2. Okay, now we got to sort. We have to apply this sort for 2 times. Why? Because for the first time you would apply for till left and mid. Now your mid becomes your right for the first part, and after that, for the second part, what happens for the second part is that your see, if it had some other elements also, see, so now what would have been this? So if this was your left, so now this would become your mid plus 1, and this would become your right. Simple. So yeah, we would be starting from your mid plus 1 till your right. So we used this part. Understood till here? After that, we use the merge procedure. What does your merge procedure say? Merge procedure says that until we get the single elements, we would break them, and when we got the uh, single elements, or the single array values, we would sort them. So this merge procedure sorts them. So you would say, where is the merge code? So yeah, don't get panic, there is your merge code here. What did it took? It took three values: your left, your mid, your right. Okay, why? I would be discussing in this video. See, int we would be finding the sizes of the two subarrays to be merged. Why? Because see, if this is your subarray of, say, till n elements, so yeah, you would be finding a particular middle element. You find out a particular middle element. After that, after finding that particular middle element, you would be getting two further subarrays of, say, if it is n elements. So if you got from here to here of x elements, so remaining would be n minus x elements. Okay, so you would be getting two further subarrays for this code. For this code you would be getting uh, two further subarrays for this also, until we get single elements. Yeah, so it keeps on dividing. So we have to calculate our two subarray sizes. So we calculated using n1 is equal to mid minus left plus 1 and right minus mid. That's a simple logic for that. After that, create two arrays. Left array, see, name this as left, name this as right. And and now we had, see, let us assume we had certain elements into that. See, 12, 1, 11, 5, 6, so on, that goes on. So in the first array, we can take this element. We have to copy now. Values don't come automatically in our code. We have to write code. Okay, so, and in the other array we copy this logic. So these are for copying your data, this logic here. Okay, now initialize the index of the first and second subarrays to be zeros. Yeah, I and j, we took two values I and j, and we gave them as zero values, and your k value to be the lower bound. So lower bound stays your 0. So k is 0. If I is less than n1, means your, so now understand this, important, yeah, pretty important this is. So please uh, keep listening. See, now this is your n1, and this is your n2, right? I would start from here and j would start from here. It would traverse while I is less than n1. See, I 0, 1, 2, and n1 is 1, 2, 3, 4. I is the size 4, and in this that might be, say, let us say 5. So your I would start from 0 to 3, and here j would start from 0 to 4. Okay, and see now, when would this come into picture? This would come into picture when you have individual array elements. See, this code would be running up till we get single array elements, because this would sort until your left is left less than right. Okay, so now assume that these elements are, we got uh, sorted elements. So we got 12 as one entity, 1, then 11 for your first array, and 5 and 6, and 5, 6, and 2 for your second array. I is here, j is here. Understand it properly, because uh, you won't be getting such type of content anywhere. So uh, this logic works. Yeah. So after that, these all are individual pieces of arrays. Okay, we got individual pieces of arrays. So I is less than n1 and j is less than n2. Okay, so now array length is 1. I when we have individual bits, we individual array items, then array length would be only 1. So yeah, I is 0, so 0 is less than 1, as well as j is here, so j is 0 less than 1, because for every this iteration, your I and j would vary. So first of all, it would be for 12 and 1 we would be comparing. So yeah, this is your left of I, that is 12, and this is your right of j, that is 1. So we check that if this is if this is less than or equal to. So in our original array that had a size of n elements, we would be putting left of I, else while we would be putting a right of j. So in our original array, what we would put? We would be putting 1. Okay, and after that, see, this procedure continues, because we would be doing merging, because we would be combining this, because this is our part number 3, sort and combine. So 1, then it would come 11, then it would come 12. So when this is over, we would be checking. Now understand this. Now now we got these elements as your array n1. Okay, and now these are your individual elements. So first sort individually, and after that we would be combining these two arrays, that is your left array and your right array. Okay, so now sort this 5, 6, and 2. So after sorting, nothing needs to be told for 2, 5, and 6. Simply we would be getting this. Okay, now we would be sorting this your left array and right array. So internally how this all is related. So now sort this. So what you would be getting, 1 is less than 2, I plus plus I came here. Now 2, because I is less than here, so j came here. 11, 5 is less than 11, so 5 came here. 6 is less than 11, j plus plus. Yeah, 6 was less than 11, and and understand this, why we did this. I is less than n1 and j is less than n2, because see, we are here out of elements now. J came, because j is our full, j is equal to now n2, but we are left with two elements in your ith position. that is 11 and 12. So now these elements are sorted in between them na. So we would be running this loop so that our array fills with these elements. So we got this. Understood? See guys, I have made my full efforts to make you understand or to ease this concept via going into the internal levels. So I hope you might understand this. So now we would be doing another question. See, and one more thing guys, um, please do subscribe and like this video, because your these efforts, only your simple gesture of your like or and subscribe would help me to make more videos, because this provides me with motivation. Your support will provide me with motivation. So yeah, let's start with this question. So now calculate the mid. Mid is 0 plus 6 minus 0 over 2. Mid is your 3. This is your mid. Sort this now. Two parts. First part. Don't go into the second part, because recursion works in this way only, as I am explaining. See, it would sort this until when? Until your left is less than right. It would first finish this whole sorting process, because it is a recursive call. It would again call this, again call this, until understanding na recursion. If you haven't if you are not aware of recursion, then I recommend you all to first learn about recursion, then it might be simpler for you all. So now this element, uh, then it would be 45, 21 and 7. Okay, no, not now. It would only, it has broken your array, so you must assume that it is another part. But for this part, first you have to solve this. So this mid would be 0 plus 3 by 2, so it would be 1. So after that, it would be breaking from here. It if it breaks from here, so we have, now we have two entities in our array, or two values in our array, that is 10, 5 to 23. Now also left is less than right, because 0 is less than 1. Yeah, so now it would, now forget about this, first focus on this. It would break into 2. So now what we would be getting, we would be getting 10 and 5. Now after 10 and 5, this is complete. Yeah, for this part. Now it would be going back here and would be parsing the part 2. So we would be getting 2 and 3, two elements. Yeah, individuals. After that, now it would again go up, and now it would parse this part. So now we would be parsing this array into 45, 21 and 7. Okay, so when we get this part, so now this would be breaking down into other two parts. Calculate the mid for this. See how to calculate the mid for this. First of all, understand this. So mid 2, 2 by 2 is 1. I'm doing the shortcut guys. I assume that you are also doing the same. Then we get as 45 and 21 as a part of an array. So divide this also. then you would be getting 45, and after that you would be getting 21. See, in this way your recursion work, it won't go till 7. Uh, when we are finished working on this, it would be going then after to 7, so we would be getting 7. So we are sorted with this part of your array. So now your merge procedure works. So how your merge procedure works, that is combine and then sorting. So in this combine here, this is your left array, this is your right array. So this would be 2, this would be 3, this would be 5, and this would be 10. After that, this would be 45, and this would be 21, and yeah, 7 also, I forgot it. So after that, now it becomes your left array. This is your left array, this is your right array. So now what it does is, now sort these two arrays, combine them to form a single array. So what is this? Then we get first 2, then 3, then 4, then after that we got 5, then 7, then 10. After that, there also is a mistake. First it would come 21, and then 45. So 10, after that 21, and then 45. So in this way your entire merge sort procedure works. So I hope you all understood this video. Thanks for watching, and hope you do subscribe to this channel.